The architecture of our catalyst switches is broken up into different planes based on the functions that are going to occur at the different planes. We have the management plane, the control plane, and the data plane. Our primary focus is going to be on the control plane and data plane, but I don't want to leave you high and dry without briefly describing what the management plane is all about. What do you think the management plane is going to be responsible for? What are the functions that are going to occur at the management plane? If you're saying management functions, you're right on there. Management functions such as the connectivity to the line consoles, the management functions based on the connectivity to VTY lines as an example, using Telnet or SSH. Those are all different types of management functions, and whatever you can think about that is management related falls into the management plane. But now the control plane, which is where the protocols and services and features are running to build the tables that are necessary for our devices to make the routing and forwarding decisions or build the spanning tree topology. That's all occurring at the control plane. And what is going to be necessary to build all these tables or make all these decisions? The processor, the CPU, RAM, random access memory. So as our router or a multi-layer switch is running EIGRP, it's going to be exchanging at the control plane EIGRP routes with neighboring devices. And then based on the information that is gathered, a routing table is going to be built, or information is going to be put in that routing table, all at the control plane. The data plane is all about packet forwarding. Taking a packet that arrives on an ingress interface and switching it to an egress interface. So switching is the process of moving a packet from an ingress interface to an egress interface. Do we want to spend our time bugging the control plane for the information that is necessary to switch that packet? Well, depends. Depends on whether you want users to be complaining that the network is really, really slow and you want high CPU utilization on your devices. If that's perfectly fine with you, then bug the control plane all you want for the information that is necessary. But that's not how we want it to function typically in our organization. We would prefer to have the information that is created at the control plane stored at the data plane. So that way there, as packets arrive ingress on an interface at the data plane, well, they can be efficiently and quickly switched from that ingress interface to the egress interface by simply doing lookups in the data plane. Can I give you a real-world example of the control plane versus the data plane? Sure, I can. Your public transportation system in your city. Buses. The data plane is the routes, or are the routes, that the buses are going to utilize. Are those routes consistent? Yeah, they are. They are very, very consistent. The drivers of the buses know their routes. But how do they know their routes? Who told them about their routes? The individuals in the meeting room who came up with the routes. They are the control plane. So the planning of these bus routes happen in the control plane. And then they were given to the bus drivers at the data plane. So that way there they could efficiently and effectively drive their buses through the cities and provide the necessary services to all the users who want to take the bus. So that is what's happening here. All the planning is happening at the control plane, and then the forwarding of our packets is happening at the data plane.